Okay, welcome to the live stream for everyone. We are doing a bit of a brainstorming discussion about Wolfram language design for stateful computation. And just sort of a reminder of what the issue is. Right now, when we, this is, let me just save this in some appropriate place here. Let's see, I'm gonna start a whole folder about stateful computation because I think this is going
There's a folder in SW notes.
What's it called?
Stateful computation.
Huh. So predictable. Thank you. Okay, great. Okay, all right. So I just want to, let's just enumerate modes of computation today, right? We have the standard REPL, in goes to out. Okay. We have, right now, we have progress monitoring, which has a slight variation from that. And we have dialogues, which we're not using much of. We have dynamic.
Right, I was just going to say dynamic. If I could find the unmute button.
There's stuff like scheduled tasks.
Oh yeah, right. Those are sort of outside of this.
Synchronous evaluations.
What's that?
I think that the point is that they are asynchronous evaluations.
Yeah, right. I mean, there's a whole
for the
category.
kernel, while dynamic is for the front end. Somehow. Sometimes.
Yes, right. But then, okay, so what I have in mind here. Okay, then something that is coming soon is evaluation graphs for infinite evaluations, right? Where that's the whole big study of there's an evaluation, it never terminates, but yet you can see things happening with it.
Wait, is this the multi stuff?
That's
Just
ultimately multi, yeah, but multi is even beyond that because there's x equals x plus 1, which right now just hits a limit and stops. But we could imagine a harness. I mean, so one case is sort of infinite computation. So we could imagine something where we say harness of x equals x plus 1. Not a very good name, but you know what I'm saying. Comma, and then some specification of what it does. Because that's a thing where, you might just say, I want to block it at this horizon or something at this moment, or I don't know what you want there. You could want a, for example, you could imagine something that's called, evaluation list that gives, moments, in the evaluation, so to speak.
We call that trace. I mean,
Yeah,
I suppose the point
trace.
is with an infinite one, you can't really do the whole trace, but right.
Yeah, okay.
Trace basically does this.
Right, exactly. But so the question is, with an infinite one, how should we think about that computationally? Okay, but that's different. That's not the subject. Go ahead.
Okay, I was about to ask, do we want to open this infinite problem right
now? No,
we
don't want to deal with the infinite case. What we're now dealing with. Go ahead.
One case that is not listed above and is probably close to what we are discussing today is streams. Like these, we do have like some stateful objects in the language already.
Yeah, okay.
Which is in and out, but with a side effect. So you read from you stream in, output out, and you advance the stream on the side without actually asking for it.
Yes. I mean, what I have in mind.
You might also include data structures too, which have kind of similar behavior.
Yes.
Okay, so look, one thing is memoizing, right? We've obviously had this, the standard memorization, idiom, and so on forever. Okay, so we've got memoizing, we've got a lot of internal caching, we've got explicit memoizing. We've got implicit caching, of which we have quite a bit. and that's something we could consider more of. Okay, so an example of that, we've got explicit caching, of which the most notable example is local cache.
Where does once fit in this picture?
That's more like explicit caching.
Or maybe like explicit memoizing.
Yes. What's the difference between memoizing and caching?
I guess it's a place where it's stored. I've never used local cache, but
Well, local
memoizing
cache
is just a down value in the end. So it stores in memory. Is local cache in memory or on disk?
it's in memory.
Okay.
I thought you could have like local caches in a cloud object and things.
Right. Yeah.
Or-
Local cache is moving something from the cloud to your local file system.
I see. But it's in a
Right.
file,
So
not
so
memory.
so local cache is file backed. And
Is
then
it file backed?
yes.
Okay.
Yeah, it looks like it turns it into a local object.
I see. Explicit persistent caching. I see. Only if it's
Now the default location is session based, so you would have to actually specify. No, sorry. Local cache is persistent. Once is not by default.
okay. So defaultly persists across sessions, and once defaultly doesn't persist. Defaultly doesn't persist across sessions. Okay, so the next big story is approximate memoizing. Which I claim is part of a machine learning workflow.
If you tell me what it is, I can.
Okay, so what I mean is, I've got a function f, and it's very expensive to compute. I compute f of 7.8. It grinds for a long time. It finally gives me an answer. Okay. Then I ask for, and I compute several other f's. Then I ask for f of 7.81. And the question is, can I get that back fast, albeit approximately?
That seems like a kind of arbitrarily hard problem.
Yes.
Well, it
Right.
is, but that's,
if it's right? If it's continuous and you have enough data, I mean, right?
I know, but that the whole point here is what I'm trying to do is we've talked about reinforcement learning and things like this, okay? And we've struggled with what the workflow is, what the computation workflow, what the mode of computation for reinforcement learning is. And I'm claiming that one important workflow is you're probing the world to try and find out what's true about it for the sake of being able to answer the question, what will this do, without having to actually do it.
Well, this is like kind of active prediction or active classification.
Yes.
We need to cycle back to those functions because they are not so well developed, but that's precisely the idea. You want to basically set up a model with a minimal amount of expensive calls as possible.
Right. But my question is there a consumerization of that idea that would be useful?
Well, one thing is, for example, you are doing optimization. Yeah, you are exploring hyperparameter cases. So you could use active prediction with the loss and say try with these parameters and try to infer what happens. If you change L1 regularization in steps. You don't want to do too many of those, of course.
Okay, but let's start off with explicit memoizing here. Okay. So testing for pure code. If we could test for pure code, we could make a decision to basically always memorize certain kinds of things. Could we not?
One thing that I'm wondering a lot about is where do we attach these things?
I don't know. That's a big issue. That's a big issue, which is why I've started off by talking about these modes of computation, because we don't have a good way to attach. Just like, right, we just have, our usual mode of computation is you have an expression, you hit it a bunch of times, you get to a fixed point, you return the result. Right? So yes, it requires a new model for that. That's why I'm bringing it up in this context. Get what I'm saying?
Yeah.
Just like, for an infinite computation, we have no idea where to attach results to. Where to attach. I mean, from the point of view of memoizing, okay, so if we say we could silently memorize in the background, right? You never need to know where it is, right? It's just an optimization. See what I'm saying?
Yeah.
There is a bit of a memory versus time trade-off.
Absolutely. Yeah. Absolutely. I mean, there's complicated trade-offs, but one could imagine something. If we could test that this is pure code, you defined a function, fg, whatever it is, there's actually no reason we can't just store the results of those things. If we knew, just like right now, we know when something has been evaluated, we know it's been evaluated, and we say we can just use the previous value. We don't have to go and reevaluate it. I mean, that's it. It's analogous to testing. Is analogous to testing whether reevaluation is necessary. Right? It's like just store. I mean, actually, I mean, internally, deep in the guts of the system and the evaluator, we are doing things a bit like this. We're just not doing it for, I mean, in other words, what is the reason why we don't just defaultly memorize a Fibonacci, for example, other than the memory trade-off, which I understand. But we haven't thought about this in 30 years. So the memory trade-off.
It's really hard to know if there are side effects. And often, the minute you use module, for example, technically there are side effects, even if it doesn't matter.
Okay. But we can define this. I mean, doesn't the compiler know if there are side effects?
Well, let me see. Almost certainly you could tell if there are more side effects. There's certainly, so there are two things. I mean, the first thing is that the compiler already only has limited support for global variables or, closures that modify variables that you pass into them and so on, although both of those things are probably going to change. But so in that sense, you're more limited in the side effects you can have. Of course, if you did something like you wrote to a file, then that would obviously have side effects. I know there's also a distinction that it's in a bunch of compiler code where it's functions are tagged as whether they're sandbox only or basically whether they're sandbox safe, but I'm not sure if that list has been maintained.
Okay. But I think it should be possible to do a side effect test. And if we found that something had no side effects, how useful would it be to memorize it? I mean, let's assume that we put aside 10 gigabytes to memorize things. We could probably memorize a lot. And we have an LRU strategy, we have some standard cache, sort of caching strategy for that. What do people think about this? Maybe we have the wrong people. Roman, do you have an opinion about this?
Well, I mean, for pure code, I mean, it's certainly worthwhile to think about it. And I assume you could, as you said, just make sure that if you actually do reuse something, then it would have a longer lifetime. But I'm not sure how how much code there is actually is that would benefit from this, however, because
Right.
not a lot of code is actually pure in the sense of not having side effects.
And not only is most code not conceptually pure, but even code that is conceptually pure is not technically pure.
I understand, but we could make the decision that certain kinds of things would be, that it isn't defined. Certain kinds of side effects. Well, I don't know. We'd have to look at. Go ahead.
Well, so what about? I mean, I think another thing that's in the same vein would be making a version of once where you can limit its sort of pool, like that it will fill up.
I see what you're saying.
Right? Because I mean that this is the thing. It's like I don't use once a whole lot, partly because I don't use memoization a whole lot. But one of the reasons that I'm always wary of using something like once is that it's like, well, am I going to accidentally be caching 25 gigabytes of stuff?
Yeah, that's a good point. That's a good point. I mean, being able to have an option to once, or even a default thing that is the once cache, so to speak, the size of the once cache.
Yeah.
Yes, but on the other hand, if you decide to use once, I mean, the reason is probably that inside there is a really expensive computation, which almost by definition is worth saving.
Yes, but the question is I understand that, but
well, sometimes like there have been times when I've wanted, so it's okay, maybe once is already not designed for this, but there have been times when I've had relatively cheap computations where I might have memoized it, but but I didn't, but I could have also used once, right? Where it's something like, oh, I'm going to call this relatively cheap function 1 million times, but of course it'd be faster if it wasn't.
How does that work? I mean, if I say f of n blank colon equals, whatever it is, the Fibonacci or something, and then I just want to onceify. If I do the following thing, if I say, I'm going to regret this because this will confuse this session forever. That's all right. I can kill this session.
While you're typing that, I just want to offer the comment that maybe it's just me, but I don't really use once for memoization. I really use it for like initialization.
Yeah, same here.
So
same here. Right, but okay, so I do this, and then I do my thing. Now, if I wrote wrap to once around here, would it do the right thing? Would it do what I expect? Would it memorize? Anybody?
I would guess, yeah, but you didn't do fib.
Yeah.
Is 20 already big enough that if it didn't memorize, it would take forever?
No, I don't think so. But 200 is. I think that memorized. Nice. How would I tell what the once cache has in it?
Okay, there's probably an example in that docs page there.
Surely you should use echo here. That should get changed.
Maybe it possibly.
Well, I mean, it really doesn't matter whether he's using echo or not, right? Since the thing that's returned is the random real. Suppose he could just do an echo of random, right?
Yeah.
That value is discarded.
Okay, sorry. What were you going to say? Where was the thing that shows the once cache?
I would have to search for it as well because I don't actually remember.
Is it actually
well, I mean, a simple test is to do a fib2 that doesn't have a once in it and see how, if that one takes forever.
Okay, fine.
And if you try this one again, it should be fast.
Well, it was very fast anyway. But let's see.
I think fib of 200 will just never finish.
Yeah, that's what I think. So I did the right thing.
Mm-hmm.
I've never used that. I've never used that. I mean, it's a reasonable thing to do, but with this point about, one can imagine a wrapper here that just says do reasonable memoization with a reasonable strategy, like LRU, for example.
But basically, it's just a programmer saying, assume this is pure.
Yeah.
Would it be an attribute of the function?
No, I don't think so. I think I think it could be almost a function that says memoize. You could just have a thing called memoize that is, well, maybe that's too extreme, but that has a bunch of stuff that has equipment, so to speak, for giving strategies and see what I'm saying? I mean, that basically then it silently memoizes it up to some limit where it is, making sensible use of, it's memoizing, assuming it makes sense to memorize. Does that make sense? So I mean, look, this is a case that seems reasonable to me. I would use this, I think, quite a bit. I mean, I think if I have code where I expect that it is, I mean, I would throw this in all the time if I think it's pure code. I think.
By the way, does it matter that I'm not familiar with this acronym LRU? I think that you.
Oh, least recently used. I think that's. It's just one. I don't remember. Roman, Christopher, somebody. I don't know. What are some typical cache replacement strategies?
I'm not sure, but I think there's, by the way, a data structure for LRU caches.
Oh.
I'm not sure it's documented though.
Well, that seems rather relevant to this.
Oh yeah, it is documented. Least recently used cache.
What do you know? Okay. So maybe this is something we should try and consumerize here. Fixed size cache where keys and values are general expressions. Well, whatever. I mean, that seems useful. Okay, but this is, the things I've been talking about here are all exact caching. There's also this approximate caching, approximate memoization idea. Do people think that idea is stupid? I mean, I was attempting to, here's the thing again, that, we have a big success with Classify of packaging machine learning in a way that's actually useful. It seems like another case is this active learning type thing or something where you're using machine learning to speed up a computation. And where you want something which incrementally does it. It's not like predict, where you say, here's all this stuff, learn it now, then I'm going to, make use of it later. It's like in the course of doing this, you are sometimes going to actually do a computation and sometimes you're just going to infer it from stuff you've seen before. I mean, it's typical active learning, practical, it's what humans do as well. Oh, I just remember that versus, oh, I have to work it out again. Julio, you understand what I'm saying?
Yes.
So, I mean, would that be useful to have something where it's like, if it was close enough, and again, it's going to require criteria, which are non-trivial, if it's kind of close enough, if you're solving some, let's say you're solving some eigenvalue differential equation-y, something or other, chemistry, I don't know what the heck it is, problem, okay? And it's like a tweak on a problem you've already solved. Well, then you might have reasonable confidence that you can just interpolate and you can get an answer really quickly, as opposed to, oh my gosh, I never looked at that before. I need to do an ab initio calculation. It's going to grind for 5 minutes.
How does this relate with the level of input that you want to cache? Like if you are thinking about like one cell at a time, but what if I'm nesting many functions? Do I cache each output? I don't know if I was clear, like f of g of f or of h of something, and maybe one, like the internal one takes a lot of time, but should I repeat the cache at each level?
I don't know. I hadn't thought of that. Well, I was thinking more that it's only the top level. That was all I was thinking about. As opposed, it's a reasonable suggestion. But I mean, the scenario, again, I'm repeating the scenario. You know, we've got plenty of places where, you know, like for example, it will be useful to us for some things where we do computations to basically ship a trivial example of memoizing that we already do is prime pi. Okay, prime pi, we know certain, you know, waypoints in prime pi, so we don't have to compute. You know, if I say prime pi of 10 to the 10, for example, I mean, another version of this is sort of waypoint memoization. Okay, so for example, if I say prime pi of 10 to the 10 plus 30, okay, it comes back pretty quickly because it probably memoized 10 to the 10. Do you understand what I'm saying?
Mm-hmm. I mean, we do this in a lot of places. We have internal caches. What you clear with clear system cache. I don't know if PrimePy is using that, but
yeah, internal caches or yeah, you know, just table lookups for important or small values, etc.
Right. Right. So,
but that is, I mean, that is an opt-in thing, yeah. And the advantage is that you know exactly at which point you want to opt in.
But it's an internal code. But I'm saying that you know, imagine you have something where, for example, we say, you know, we have a function that says, you know, approximate or I don't know, let's say learn memoize, bad name, okay, of f of x, whatever it is, right? And here we give a lot of parameters about, you know, here are parameters that say how close do you have to be, how certain do you have to be, et cetera, et cetera, et cetera, before you just say, and then you do that, and then when you say f of 0.8, you compute it. Now you do f of 0.85, you get a value. Now you do f of 0.81, and by the way, it doesn't have to recompute it because your parameters are such that it says just it's probably going to be okay. You know, if 8 and 0.85 are only 1% different, and who knows what the criteria are. You get what I'm saying?
Yeah, this is mostly impossible if you have black box code, though.
No, it's impossible, Giulio. This problem is impossible. Just like classify is impossible, predict is impossible. Every machine learning function is impossible.
This is no, this is a whole different level. I mean, I could define a piecewise function that returns a graph between 8.1 and 8.2.
Yeah, guess what? If I run that in predict is going to fail.
Yeah, sure.
It has the same level of possibility or impossibility that predict has.
I mean, is this not like active predict, basically?
It's active predict. It's basically a packaging of active predict.
But is that actually useful? Because active predict will almost certainly be slower than running this function.
Well,
and if the function, if the function is reasonably cheap, then active predict will probably be slower. And if it's really expensive, then I think that the sort of automatic caching will probably not be enough to sort of get around the fact it's really expensive.
Okay, look, the scenario that I have in mind is, let's consider, I don't know, computing something in chemistry where you're gradually increasing the, you've got some whole complicated thing. You've got a 30 parameter object that has different, atoms in different places or whatever else it is. Okay. And it's a 30 dimensional space. And you are, and it's pretty smooth. The values of the function are pretty smooth in that 30 dimensional space. Yes, for every separate value, you can go in and compute. I mean, I've got millions of examples of this, although I can't think of ones immediately. But there are plenty of examples where it's a high dimensional space. It's pretty smooth, or you can deduce that it's pretty smooth. Now, of course, it might not be smooth. It might be that it's smooth except for this one little tiny hole in it, the black hole in the otherwise smooth space. But predict is going to fail at that as well. Making sense? This is not as dumb as an idea as you guys are making it seem like. This is
right. Well, let me just, I don't know exactly what examples you have in mind, but I would point out that in chemistry, right, that singular space is not going to be a point. It's going to be a hypersurface because it's called a phase transition.
Well, for example, that might be one thing. Yes. But I mean, the whole point is predict is going to fail at all those things, right? So if predict is useful, which it is, it can be used for these purposes too. The only question is the packaging of predict, because predict is a learn once, it's go to school early in your life and never learn again type thing.
Well, there's one big issue here though, like predict is a numerical univariate functions that it approximates. If you are talking about something that can work for every possible output in the language, even if it is well behaved.
No, let's just box this problem in for a minute, okay?
Mm-hmm.
Even if it is multiple numerical parameters in, which predict also deals with, to one numerical parameter out. If we consider that case, right? Now, obviously, you've got a decoder, net decoders and so on, which potentially can lead to more complicated expression structures as output. But I don't think that was not what I had in mind. I was more interested in things where the output is fairly straightforward. Okay, and where
but this is a very narrow applicability window for something this general.
I don't know whether it's that. Okay, look. I don't know how we package this, okay? The concept would be to have something that is ultimately quite general, although it might start, this is, okay. This is kind of a continuous analog of programming by example.
No, okay, but take something like adjacency metrics. Sorry, adjacency graph. Metrics in, graph out. It's
hopeless.
It's a huge space.
Hopeless.
It's hopeless,
and isn't even useful for this. The case where this is interesting is where there is an internal computation that is solving some differential equation or this, that, or the other thing, or doing something where there is some expectation of continuity. That's the same. Let me remind you, machine learning is impossible, right? And it's only going to work if there is some simplicity in the world, so to speak.
Right. I mean, the question is, is this not just like a Taylor series or interpolation or something?
It might be. It might use interpolation. Yes. It might use, it might use fancy machine learning. It might use interpolation. It might use some straightforward machine learning. The point is more packaging than it is methodology inside. I'm not worried about us being able to do this internally. I mean, Julia was right that to return an arbitrary expression is much harder, but to do this in the same way that active predict does it, for example, the innards should be fine unless that function is horribly broken, which it might be.
And you would use it like you use the once in the definition of Fibonacci recursion?
Exactly. You would put it in there, learn memoize would put in there with f of x in the definition, right? But learn memoize would have certain parameters which tell it, use it in this way. I mean, just like, predict, no doubt, has certain parameters, although it has a lot fewer than you might think. So, I mean, the concept here is that this is something where if, and by the way, okay, so let me give an example of where this is complicated and where once, okay, here's the issue. Let's say that we have one of these things and it's for some chemistry thing, whatever it is, and somebody evaluated its sort of key memoization points. Okay, and there's 1 megabyte of data associated with those memoization points. So what we need is a workflow, and maybe it's just the cloud, where that memo data can be transported around. Do you see what I'm saying? Because usually when you define a function with learn memorize there is no, we can have an invisible cache and we don't have a problem with that. But our standard evaluation workflow does not allow for, I think somebody had raised this earlier, where do you store this stuff, right? And once stores it in the ether of the local session. See what I'm saying? So the question is, where does learn memorize store its megabytes of data that is its memoization, is its prediction function? You understand the question?
Well, that's going to be this probably a similar thing as what we have for persistent value.
Yeah, I would think so. I mean, we can use that framework for that. But so, yeah, right, fair enough. So then it can store it in the cloud, it can store it locally. There's a question of where the defaults are, etc. Right. But I mean, okay, my goal here, the reason that we brought this up is because I was trying to consumerize some of the pieces of machine learning that are currently not consumerized and never used by people, like active predict. Okay, so Giulio,
Okay. Yep.
respond to that. I mean, to me, this looks sensible, right? Particularly if we think about using the persistent objects mechanism to store the backend caches. This looks quite sensible to me. I mean, it's like storing a very local neural net repository entry that's just associated with this one function. You push it into the public cloud and it sits there waiting for the cache to be used. You're very hesitant. What are you hesitant about?
Well, it sounds very unexplored. So before, like, I would like to spend sometimes exploring this and banging my head against the problem.
Okay, well, but you understand the objective.
No, I see your objective, and I see how this could be useful if implemented correctly. And it's true that active prediction as it is not very useful. So if we make the idea, if not the function, useful, that's nice.
Right. I mean, so let's review for a second. You know, where people would use this is just an expensive numerical function where they would just wrap this wrapper around it. So that, I mean, it is making a reality out of the claim that we are increasingly making, that machine learning is the future of interpolation, so to speak. That, a lot of numerical analysis can be done better with machine learning type methods than it can be by the traditional methods. Mm-hmm. And this is basically consumerizing that idea. This is a good idea. I'm sorry. I think this is a good idea. I think we've got two good ideas.
Don't be sorry.
We've got two good ideas. One is a version of Once that has reasonable memory, cache memory usage strategies, so that one can put it into with wild abandon in one's code without worrying about it, and just like, well, it'll make it faster if it can. Make sense?
Mm-hmm.
And that will be strategy one. Strategy two is to just do that behind the scenes automatically, but we think that's too dangerous because of pureness of code and things like this. And maybe it's also pointless, because most of the time memoization is utterly pointless, because most computations are fresh, so to speak.
The thing that scares me about this is subtleties of evaluation semantic. Like, for example, you put once there in the Fibonacci definition. if you have something like module m equal n, and then you put ones inside that, it doesn't have literal n anymore. It has a module variable.
Yeah.
Like, I mean, I think that's one of the reasons why, I mean, one of the things, like, if you had a memorize function as well, it might make sense to make it a headdress, right? Because then it would struggle with attributes, but it would at least get, you know, it wouldn't struggle as much with like module variables.
But so you think on the left hand side of that assignment, or once you run it?
So I think the idea would be, you'd say, let me see, I think this makes sense. You'd say once a fib of n-1, once a fib of n-2, etc. And then I think the idea is that, right, that way the n-1 will just evaluate, and then, you know, that's not part of the thing that's held. Instead, the only thing that you know is that the head was fib. The only thing you have to cache is that the head was fib and that the input was whatever it was.
Okay, so that's
but they still wouldn't solve the case I was making. Like, if n is not passed as value, you don't see it at that point.
Well, no, I think you would, right? So if n was a module variable, the point is that the n-1 and the n-2 would evaluate.
Oh, you want to let it evaluate before? Okay.
So you wouldn't get attributes, right? If fib had attributes, this would mess it up.
Yes.
But yeah.
Well, that's a different idea. I mean, it's a related idea. But
I mean, honestly, I think for memorization, that might be how it would have to work to get around the module problem.
This is a big problem, Stephen. Like, even when you're doing like opt-in cache, like in, I mean, the way we write internal code is the way people could write code, and I think that a lot of people wrote their own caches. And the thing is always, if you want to generate the cache key, what are the things that you want to evaluate to generate it?
I see.
And some of them might be relevant, some of them might be not relevant. Like, for example, just something I worked on recently, those impact plots. Mm-hmm. I'm caching the sharp values. This is a slow computation. If you want to change the color of the points, you don't need to do that again. You want their output immediately.
Yes.
Something like word cloud. I tried several times to make a cache, but there are like just too many. You know, you could set options of a cell, and that would change how stuff is displaying on screen. So there's no way to cache the shape of the words in a way that,
right.
that you have just basically every front-end option and cell option and input option. So in that case, the parameter space is that's not cacheable. But in some cases, you have clear mental model of what are the relevant.
Well, okay. So the question is, right. So this is, cacheability, and what can what you are doing actually depend on, e.g. front-end options, etc., etc., etc. I mean, so that is a question of something that we are interested in for other reasons. Like the compiler cares about this, lots of things care about this, of how pure is something. Where are its sources of impurity? Or, external.
Did you want a list, or?
Well, I don't know. What were you going to provide a list, or?
Well, I'm just, yeah. I think there are lots of places where impurities can enter.
Right, but if we knew all of those places, if we can enumerate them, we can detect. I mean, then we can answer the question: is this cacheable?
Well, one of the issues is not only is it that there are lots of places. I mean, there's things like the file system, there's system options, there's whatever. There's the symbol table, but there's also things where it probably depends on, it might be hard to, like, if you flag things at the coarseness of entire functions, that may be too coarse. Like, there may be things where, well, import is pretty much always pure, except for this one import, which isn't, right?
Right.
One interesting question is, where do we want to stay? Like, we have some code. I think, Ita, you fix some of Tali's code there, like some evaluation, like might evaluate stuff. Like, is like,
oh, like the like the has down code, but
Exactly.
yes, has possible evaluation skew.
Exactly. So the thing is, like value queue, for example. Yeah, like you want to.
Yeah, this is the question.
If something is like, do you want that the true is always true? So if you say that it has side effects, are you fine if it doesn't have it, but you always catch when it has it, or the opposite? I'm sorry, I'm tired, but you see my point. Like, do you want to flag the code as safe, even if when sometimes it's not safe, or the opposite? You want to absolutely be sure that.
I don't know. It depends on what you're trying to do.
Exactly. So for this problem, we might decide to err one way or the other. Yeah, like to memorize when maybe it's not necessary, or to not memorize when it would have been necessary. And that depends on where do we want this thing to lean. Like, is it an aggressive thing that if you opt in,
I don't know.
Yeah?
I don't know. We have to think about it. I mean, we've got two different cases here, right? We've got the case where there's a bunch of semantics issues to do with exact memorization. And then we've got the case where there's a bunch of algorithm issues to do with approximate memorization. Those are the two things we need to.
Should the approximate memorization do, like, is it a superset of the memorization or not? Like,
I don't know. I think it's related. I think that the mechanisms should be similar, but I think that this whole question about the evaluation semantics, I don't know how important that's going to be.
No, sorry, I'm asking a different thing. Like, if you ask f of 1, and when this approximate memorization, if I re-ask for f of 1, should it use like the machine learning thing, or for like the stuff that it has already compute, it should be exact?
I don't know. I think that's an option. I think it's an option. I think it depends on what you're doing. You know, sometimes it would be better to use the consistent machine learning stuff. I mean, like for example, here's a good question. If you ask for f of 2, and you're in a mode where f of 2 is deduced automatically, okay? And then for whatever reason, and then you compute f of, this is a good example. You do f of 2, it's computed automatically. Then you compute f of 3, which for whatever reason is explicitly computed. Okay? That then changes the inferred value of f of 2.
Yep.
Right? I think that's life. I don't think you can avoid that. If you're going to have a learning function, that's what's going to happen. Right? Even a thing that you requested before might change its value as a result of new learnings, so to speak.
Yeah. That's, I mean, if you're opting into machine learning, that's what you get. Yes.
Right. So,
as long as it's statistically sound, like it shouldn't change statistically.
Even a value that you requested before might change when another explicit computation gets done. Right. I need to run off to something different here. But I think both of these things I really think are worth exploring. I think they're both pretty decent ideas, and especially with your admission or statement that there's a lot of internal code that uses caching. Let's figure out how to consumerize that. You know, and that again becomes the Christopher semantics issues. That's important there. For the machine learning thing, we need an algorithm. We need to know, could active predict just do this out of the box? Right?
Is active predict like a function that I don't know about?
Yes. Yes. We don't talk about it, but yes.
Well, we don't talk about it. I mean, we spent a lot of time working on it, and then
I don't know the history of active prediction, but yeah,
it was at least 1 or 2 years of work. Okay, it was a lot of time was spent on it. I think Amir was the primary person who worked on it. You know, a lot of time spent on this, and it's never used because it is not packaged in a way that anybody could, can use it. And that's the goal here, is to provide, good packaging for this. See, this is exactly what we're looking at here. Predictor function. There you go. Now you add more values and you can predict better. It's exact same thing. right? It has all kinds of parameters, et cetera, et cetera, et cetera. We need to understand how those are more consumerized, but that's kind of the idea.
We should have, I don't know, do we have any interesting example here in this page? Because I mean, this is, of course, you'd never want to use active prediction for doing +2, but you probably want to.
I have no idea.
Yeah.
I don't know. I was not pleased with this project, basically.
Okay.
I mean, I think maybe the raw this project was never packaged in a consumerizable way.
Okay.
Okay, and that's the goal here, is that the chances are all of that algorithmic work can just be used if we can find reasonable packaging. All right, I have to run, but
Okay, thanks.
see you later.